All right, Arizona 201, sieving and washing. Your sample's gonna come in from the field. You wanna make sure your sample's in a flowable state, making sure there's no clumps, there's no dirt clods. Once that happens, your sample size is going to be according to the table in the procedure. Once you have your sample size, you're gonna weigh that to the nearest whole gram. You have your sample, you have your nest of sieves. Introduce it to your sieve, and you're going to sieve this either by hand or a mechanical shaker until thoroughness of sieving is achieved. All right, thoroughness of sieving is achieved when no more than 0.5% will pass through any sieve of the total sample size. And the way you would check for thoroughness of sieving is that you will hold a sieve with a pan and a lid in an inclined position, and at a rate of 125 strokes per minute, you would tap that. And then every 25 strokes approximately, you would turn it 1/6 of a turn. One-sixth of a turn. And you continue that for 1 minute, and then get the weight of the passing material and make sure it's not more than 0.5% of the total starting weight. Once thirds of sieving has been achieved, weigh each sieve. Weigh the material from each sieve. To the whole gram. And you continue that for each sieve. And as you're weighing each sieve, you also want to make sure the sieves are not overloaded. And the way you can find out that a sieve is not overloaded is there's a table in the procedure where it gives you how much each sieve can be retained. And as you're weighing, as you continue to weigh each sieve to the nearest whole gram, you continue that all the way down into your bottom pan, and then you're going to total up the total weight. That total weight has to be within 1% of your starting weight. If it is within 1% of your starting weight, then you can adjust the sieve that has the most retained, but you cannot adjust your pan. That's not a retained weight, that's a passing weight. So the sieve that has the most retained, you will adjust that sieve to make it equal what your starting weight is. Okay, so now that you have your pan, this is the material that you're going to wash to find out how much your 200s are. And in lieu of washing this whole entire weight, you can reduce this to not less than 500 grams. Record your -4 material to nearest whole gram. Okay, now that you have your material from your pan, you weigh that to the nearest total gram. You can reduce this according to R76 to not less than 500 grams. All right, that's not less than 500 grams. And I would take this, and this would be my wash sample. All right, Arizona 201 washing. You have your material in your bowl. You have a 200 screen on the bottom, 16 screen on top to protect your 200 screen. Place water in your container. Agitate it to get the fines in suspension. Decant that over your 16 and 200. And you keep doing that until the water runs clear. Decant until the water runs clear. Okay, water runs clear. And then wait for the fines to settle. Once the fines have settled, decant the water. And then drive this back to constant mass in a way that you will not lose any material due to splatter. Take this out, let it allow it to cool, weigh this to the nearest whole gram, and then do your fine sieving. Fine sieving is similar to coarse sieving. You have your nest of sieves, you have your starting weight to the nearest whole gram, you pour the nest of sieves, and you sieve it either mechanical or by hand until thoroughness of sieving is achieved. Again, thoroughness of sieving is defined as no more than 0.5% of the material can pass any given sieve of the total starting weight. Once thoroughness of sieving is achieved, you take each sieve, weigh each retained to the nearest whole gram, and continue all the way down, and make sure you're also checking to make sure that each sieve is not overloaded. Overloaded for fine sieving is different than coarse sieving. Fine sieving is defined that no more than 4 grams per square inch can be retained on any sieve. Once you verify that the sieve are not overloaded, and you added up each sieve retained weight to the nearest whole gram, all the way down and including the pan, you weigh up everything and make sure that's within 1% of your starting weight. If it is within 1% of your starting weight, then you can adjust the sieve that has the most retained, except you cannot adjust your pan, which is not a retained weight. After that, you calculate your percent of your 200s to the nearest tenth of a percent.
Addendum to Arizona 201, Elutriation, Section 5.1. A representative minimum 500 gram sample of the passing number 4 material is to be obtained using a splitter in accordance with AASHTO R76. Mechanical washing, Section 6.2 through 6.4. The washing device is filled to the bottom of the window and the sample is placed into the device. Section 6.2. The sample is agitated vigorously enough to cause the material to go into suspension by using the water tube and air if necessary. Section 6.2. Continue washing until the wash water is clear. Section 6.3. Wash the sample into a container large enough to hold the water and sample. Allow the particles to settle and decant the excess water. Section 6.4. Dry the sample to a constant weight at a temperature that will not cause material to be lost due to splattering. Please be sure to read all of the materials available in your Soils and Aggregate Technician Certification Workbook.